Hey YouTube, it's me, Rosen, and I'm here to give you a talk I gave at JS Talks 2022, and it's about building a design system and how we did it at my company. Hope you enjoy it. First, let's talk about what are design systems. When I first started researching that topic, I thought that design systems were component libraries. And if you'd asked me that question 5 or 10 years ago, I'd give you a different answer. For example, 10 years ago, I would think of a design system to be something like Bootstrap. Longer ago, I would say that it's something like a style guide for writing CSS and how to structure your HTML. In recent years, design systems such as Fluent and Material became very popular, but when I checked their description, it didn't sound like a framework, but like something vague and mysterious, something like a superhero entity. So I decided that I'll try to find a clear definition and try to present it to you. So let's dig into it. What is a design system exactly? It's something more than a style guide. It's more than just a components library. And it's not just a CSS framework. And it's not only guidelines and documentations. So what exactly is it? For me, as an engineer, I see it as a common language between designers and engineers, and a good design system should empower designers to code and engineers to design or to be part of that process. So let's look at the different parts of the design system, and hopefully that will make it clear. So as I said, if you've never heard of a design system, probably a components library would make most sense. And on top of that, you have guidelines for how to use the components, how they interact, and so on. But it's not enough to have a bunch of components clumped together. There should be clear guidance on how the components should look like, how they are implemented, how they interact together, what is the use case for every component, even more importantly, what it shouldn't be used for. But there should be an even granular part of the design system that we can use to build these components. In our case, these are the tokens. Tokens are the smallest part of the design system. They are the building blocks of the components. The best definition I've seen is that they are context-agnostic primitive values that define visual styles. Later, we'll dig deep into what exactly tokens are, but for now, you can think about them in terms of defining color, spacing, and typography. On top of components, we have page layouts, which define how components interact inside of a page, how the page is structured, what's the skeleton of the page. It defines the grid and the spacing between the components in order to have a consistent layout. In order to have a consistent layout, we need to know our use cases, understand how the information on the page will be used. We need to prioritize our content and organize it so that it highlights the most important information. We need to group the related content together in order to make it easier for the users to work with. And on top of that, besides the guidelines, we have documentation and playgrounds. A good rule of thumb to follow is that if something isn't documented, then it doesn't exist. And the playgrounds are the place where you can see your components and layouts in action. You can see how they are used and how they behave. Besides layouts and components, we have interaction models, and also voice, tone, wording, grammar, and mechanics. Let me spend a couple of minutes explaining what interaction models and voice and tone are, and hopefully point out their importance and how they play inside a design system. What is an interaction model? How does the user interact with your system? What are the devices that are used? What are the environments? What's the time in which the user uses your system? Let me give you an example. In my company, we develop a software for managing medical centers and patient engagement. Before the patient takes an exam, we send an SMS with the link to an online form which can be filled before the exam so that the patient can save time. When the patient comes to the center, he then has the option to either fill the forms on a tablet or on paper. And later, during the exam, the technologists can ask screening questions, which can also be filled on a tablet. So here you can see the patient can use mobile phone, tablet, laptop. It can be even paper, and the environment also changes quite dramatically. You can be in the comfort of your home, or you could be at the modality where it's a dark environment, and where it's a dark environment and you're using a tablet. So it's important to make the patient feel comfortable and confident in the product. The paper forms should follow the same design principles as the online forms. They should follow the same voice, the same look and feel, so that the patient can have a smooth transition and is confident in using our product. Using the previous example also illustrates the importance of voice and tone. You can see here in the example the difference between the two error messages. One gives no useful information, the other is soothing and also gives proper guidance for further action. The tone reflects different emotions such as empathy and humor that add clarity and personal touch to the product. Now that we have a better understanding of what a design system is, let's talk about shall we build one? The way to answer that question is to ask yourself, are there villains working around in the shadows of your project? Are there repeating problems that you are facing daily that you can't solve? A villain is a well-framed and well-named problem. In the case of the design system, they are fairly evident. Make the evils evident and crush them by bringing a hero. So let's start defining these villains. The first one is inefficiency. When you don't have clear guidance or tools that help you build your product, then you're doing the same work in order to build the components again and again. Changes in multiple places instead of just one. And when doing redesign, this is really costly. A favorite quote of mine basically said that at first you can live with the inefficiencies, but as your team grows, as the company grows, as the product grows, these inefficiencies become tough to manage and they become exponentially wasteful. The next villain that might be working at your project is insecurity. And I think this might be the most important one because it builds lack of trust and confidence in the users of your system. When you don't know what the best practices are, whether you don't know which components should be used, or are there even components for my use case, then it's difficult to make a coherent design. How the components sits inside of template. Let's think about the submit button. How this button sits inside of a form. How this form sits inside of a layout. And how this layout is presented into different interaction models. This problem should be solved once. This problem should be solved once and not every day using different tools and different principles. The last villain is inconsistency. Some user actions are done differently. Yet again, users lose confidence and they must learn again how to use your product. An example here is a model dialog, which in one place is closed using an escape button, in other is closed using a close button at the top right corner, in other with the OK button at the bottom right corner, and in other you just click outside. So the user has to learn how to use your system again and again, and it's not confident in their actions. Building a design system requires a dedicated design support, be it a team, a freelancer, or someone deeply invested in the project. It's essential for developing a consistent and evolving brand, which relies on both effective design and development. The design system should be built for change and evolution. Now let's focus on the primary building blocks of the design system, the tokens. Tokens are crucial for efficiently managing design systems. They help better translate the design to the development and help you maintain high consistency across product UI and UX. Let's walk through a collaboration scenario between an engineer and a designer and see how tokens can really help. We start building our app and we want to set the color of the logo, for example. We go to the designer and ask him, what's the color of the logo? The designer says, oh, it is flat onyx. What does that mean, says the engineer. What's the hex value? And the designer says, it's this one unless someone updated it. We sync the value, we put it into the code, However, a week later, the design is changed and now it's a slightly brighter color. What we have to do? We have to go and manually replace all of the hex values. Instead of that, we could have used a token, for example, a brand. Then when the designer updates the token, we just get the latest version and it's automatically updated in our app. What are examples of tokenizable values? Which are our global tokens? For example, color, opacity, shadow, font size, border, spacing, and more. Let's continue our collaboration scenario. Now, weeks go by, we are up to speed, now we have a couple of components implemented, and they all use our global tokens. However, the designer this time decides that the toggle and the checkbox should use a different value for its color than the button. What do? We now have to go and manually replace all of the colors for these components. A solution that would help us automate that process would be to introduce a new layer of tokens. We can have different levels of alias tokens. For example, we can have semantic tokens that each component uses. Semantic tokens are used in multiple components, for example, the color of the text, and also in different parts of our application. Whenever we change the semantic token, everybody who uses it gets the updated value. However, if we want to have a more granular update, we can have component tokens, and these tokens can point to our semantic tokens. So now, when the designer wants to change the value just for a certain component, only the component's token value is updated. If we need to update the value for multiple tokens, then we update the semantic value. And if we need to update the value across the application, then we update the global token. It is useful to have a convention for naming specific tokens so that they are easily recognizable. For example, we can use sentiment, usage, prominence, interaction to name our tokens. For example, we can have selected text default hover. In order for the engineers to not have to go and manually update the tokens, a good idea is to find a way to automate the process. In our case, we use Figma for the designs. We connect Figma with GitLab, and every time there is a change, the designer commits to our repository. Then we have CLI job that runs style dictionary and transforms the tokens which are exported in JSON into CSS. Then it automatically commits the updated values to our repository. Now we can use them in different parts of our application. This way the engineer doesn't have to do anything. He just needs to pull the latest version and everything is updated all across the board. Now that we have our tokens, let's start building our components. Let's talk about API design. What is the API of a component? We need to define how the component is used. What are the inputs and the outputs? We need to be consistent with namings. A good rule is to use prefixes in order to avoid name collisions. Another useful rule is to try and limit the number of inputs and outputs so that we avoid attribute explosion, which makes our component difficult to use. It's important to keep in mind where and how the component is used. We should avoid passing functions or complex objects as inputs. It's become difficult to type check and there could be hidden gotchas. We should think about when we should use inputs and limit the component's usage to configuration, and when we should allow more freedom to the user of our component to insert custom HTML. The next thing to think about when building components is dependencies. A good rule of thumb is to avoid other dependencies beyond the framework that you're using. For example, if you're using Angular material, stick only to that. The best case, in my opinion, when building a design system is to use headless components or no library at all. Regarding tooling, I'd say best stick to what your framework provides. Usually best practices like optimization, backwards compatibility come out of the box. When it comes to testing, linting, and formatting, I'd say when doing unit tests, look for an option to test them in the browser, like Karma. This way your unit tests are closer to the real world. Set up linting and formatting. This way, whenever someone has to contribute to the design system, there are strict rules that he has to follow, and he doesn't need to second guess whenever developing. Schematics are a useful tool to ensure that your design system is used properly, and whenever you introduce changes, the transition is smooth and the consumer of your design system is compelled to use the latest version. Let's talk about documentation. What else lives in the design system? On top of all that, we have documentation, we have usage examples, and we have guidelines. One very useful tool that we use is Storybook. I think it's very popular, so I'm not going to spend much time advertising it. What are its benefits? It helps you develop the component in isolation, which is very useful because sometimes the components might have some strange edge cases that could take a lot of time to set up in your actual environment. However, here you just set up all of the proper props and you have the correct scenario loaded, so you can easily develop and test your component. Another cool feature is that you don't need a local setup. Your project might require a couple of services to run and a couple of applications to run in order to have everything set up and ready to be tested. With Storybook, you don't need all that. You just need to run Storybook and you're good to go. This allows your designers, for example, to jump in and quickly tweak something. Also, Storybook provides integration with Figma and other design tools, so it makes it easier to quickly check how the component should behave and test that in the playground. Things to keep in mind when developing your design system. Flexibility over rigidity. It's crucial not to force applications to strictly conform to your design system. This approach allows for adaptability to specific project needs without compromising the integrity of the design system. Gracefully handle exceptions. The design system should be robust. Graceful exception handling. Design system should be prepared for unexpected scenarios. That prevents minor issues from escalating, ensuring both a smooth user experience and reducing development headaches. Another thing to keep in mind is accessibility. Incorporating accessibility from the start ensures that the design system is usable for all. Expanding your user base, it's about building a venue that everybody can access and enjoy. Regular testing in SSR ensures compatibility and performance, preventing last-minute surprises and technical debt. It's like doing regular quality checks during the manufacturing process. Adding features only when you need them keeps the system lean and performant. Avoid bloating and reducing maintenance overhead. Limit direct DOM manipulations. This can prevent conflicts and performance issues. Each step, from understanding the basics to implementing sophisticated tools, plays a crucial role in crafting a cohesive, efficient, and user-friendly design system. Hopefully, this video helps you build one. If you have any questions, please leave them in the comments. See you in the next one.